If you remember, a couple of weeks ago, we have introduced Launchpad v2 during our Graph Core Dev update. And today we will be doing a follow-up of demoing how to take the user from having one Kubernetes cluster to a full integration with Launchpad components, including deploying a chain. Our chain of choice will be Eat Girly. Before we follow the quick start guide, which you can find in our docs, let's quickly remind everyone what Launchpad v2 is comprised of. So we have a Launchpad starter, so the starting point for every new Launchpad deployment, which gives everyone an opinionated way to define and manage your stack in a declarative and version controlled manner. Then we have a collection of Helm charts for deploying and monitoring all of your blockchain nodes and graph protocol indexers in Kubernetes, as well as other supportive charts. Launchpad namespaces for pre-configured namespaces for core cluster functions, so login, monitoring, ingress, storage, and major blockchains. Launchpad namespaces comes with stable and canary release channels for tracking updates based on an indexer's risk appetite, and it also contains feature toggles, so opting in and out of some of releases, as well as offering flavors, so pre-configured namespaces that based on whether you are deploying against Garlic or Mainnet or similar options. In addition, there is an automated dependency update pipeline for Launchpad charts and Launchpad namespaces. And with that, let's go back to our quick start and follow the guide. So first things first, if you haven't already, make sure you meet all of the prerequisites before starting. So understanding of infrastructure, basic knowledge of Git and GitHub, understanding of a graph protocol indexer and its stack, as well as some operational requirements for indexing, a client machine which will be used for interacting with your Kubernetes cluster, and the most important thing, a Kubernetes cluster. So Launchpad v2 requires you to provision a Kubernetes cluster ahead of time. This Kubernetes cluster can be a self-managed cluster that you have deployed yourself, for example, with something like Fedora CoreOS, or a managed cluster for that you would have provisioned using a cloud provider such as AWS or GCP or Azure. In addition to these options, we have added a Kubernetes guide that shows you how to manually install a Kubernetes cluster using the kubeadmin tool. And this is a great way of starting to get your feet wet into the Kubernetes cluster type of components and just getting a better understanding of what it takes to have your own Kubernetes cluster. So please, if you don't have a Kubernetes cluster, if you don't have the experience, please do check out your guide, this guide. And with that, let's start deploying some stuff. So first things first, you will need to install task file. I will skip this step because my machine is already set up with task file, but there's installation instructions for this, and task file acts a bit like makefile, and we will be using it to run all sorts of commands and tasks, as you'll see in a minute. Next, we will be using the Launchpad starter to create a new infrastructure repo, which will become our new infrastructure our new infrastructure working environment. So to do that, I will be copying this command to clone it onto my machine. And now I have my new infra repo. This you can call whatever you want. It doesn't have to be my new infra. And if we open it, you will see straight away that the contents of this repo include everything that Launchpad Starter has. And from here on, you can customize it according to your needs. And you'll see that in a minute as well. Now, the next few steps are for pushing this repository into GitHub so that you can collaborate with your team and track it easily. I will not be doing this because this is a demo. So skipping straight to setting up Launchpad dependencies. So for that, we have a task, so Launchpad setup task, which will install all of the dependencies needed for running Launchpad v2 plus additional tools. While this is installing, you can see under task file in your My New Infra that we have dependencies for Darwin, so macOS and Linux operating systems. And if you are not running one of these operating systems for your client machine, do feel free to contribute to another Launchpad with another Launchpad dependency file, and we can help you with that setup. All right, so the setup task has run. So we have Helm, Helm file, Customize, GUM, kubectl, kubectl, Octant, K9s, and some Helm plugins. Now, before we move on, if you wanted to see all of the tasks available, you can just run task. And you can see here that we have, this is what we run, so Launchpad setup, and it gives you a description. And throughout this guide, we will run release apply, release list, plus a few others. All right, going back to our guide, the next thing would be connecting your Kubernetes cluster with your local environment. So you have some instructions on how to do that. I have gone ahead and have already done that, and I can show you how I've done that by running kubectl config get context, which shows me the cluster I'm running against, context with an S. So I am running against the demo cluster. So to be able to see this, you would have to run through this instructions that make sure that your kubeconfig file has been added, that your kubeconfig file has been added into your environment. All right. At this point, we now have our own private Git repo containing the declarative configuration for our cluster deployments. We have installed all the tooling dependencies on our local machine, which will then be used to control the cluster namespace. So now it is time to customize our Helm file and deploy some namespaces into our environment, into our Kubernetes cluster. So to customize our Helm file, what we will do is copy, so duplicate the sample Helm file that exists in our new infra repo into a Helm file.yaml that then we can customize as we please. So let's just quickly have a look here. So one thing we will be wanting to do is check our Kubernetes version. So if we run kubectl get nodes, it shows us all of the nodes running in the Kubernetes cluster, without typos, of course, plus the version that it is running against. So in our case, this is all right. Then there is a Launchpad namespaces section, and you can see here Launchpad namespaces references. that tell this repo go and fetch the Helm file declared in Launchpad namespaces repo. So let's have a quick look at Launchpad namespaces. I have it here. It leverages Helm file to provide a declarative way for deploying and managing functionality related to bundles of Helm charts. And we have a README here that shows you how to set up a Helm file.yaml, which we have already provided with our Launchpad starter copy, my new infra. It tells you how to override namespaces and release values. So for example, you can choose to change a namespace, you can add additional labels and so on, and then you can also override values for each release, which can also be done in the values section of the Helm file, but can be done by providing separate files, which we will talk about in a second. And finally, we have at the beginning mentioned different release channels. So if we look into our my new infra here, the release channel is stable. But if, for example, you wanted to install something different than stable, we would we would update this, and we have an example here. So I will go into tags and let's say storage, because that's what I'm looking at. There's a storage v1 and there is a storage v2. Let's say we run this instead of stable latest, and that is one way of customizing what namespace you are running into your Helm file.yaml. We'll not save that, but just so you know. Okay. In addition, Launchpad namespaces contains definition for each namespaces that you'll be running. So for example, if we look into Arbitrum, it has a Helm file itself that is similar to our Helm file. So our Helm file here is an extension of this Launchpad namespaces Helm file. Then we have additional values, default values of how to set up your charts within Helm files. But the most important thing is each one of these namespaces contains a README, so that you can have an idea of the releases a specific namespace will install, plus additional instructions, as well as all of the different key values that are possible to set up. All right. So we've looked at our Helm file section. As we said, you can override values, you can select which namespaces you are interested in, and yeah, for more details, please look at the namespaces documentation.
At this point, we are ready to sync our newly created Helm file.yaml with our cluster. Now, the first thing would be to install the key non-graph components of our stack, and those would include monitoring, logging, ingress, secrets, and storage. Now, to do that, we have created a special task. So if we run task, you can see that there is here the task releases apply base, and if we run task help, releases apply base that will tell us what this task does behind in the background. And this task basically runs another task, so the main apply charts task, so task releases apply plus the selector or the label GraphOps Launchpad GraphOps XYZ layer base. Now before we run this command, it's important to know that there is another command. This is task releases list, and this command will list all of the releases that have been defined in our helm file.yaml. That is irrespective of whether they have or have not been installed into the cluster. And those releases are, you can see the list here. So you can see, let's just do this. Alright, that's better. So you can see the name of the release, the namespace it applies to, its labels, and the chart with the version of the chart. And again, these are releases that are defined in our helm file.yaml. So here, or are coming from Launchpad namespaces. Now, if we did want to see the releases that have been installed into the cluster, there is a helm list command. So this is helm list -a for all namespaces, and this will show us what is currently installed in the cluster. So because we haven't yet run anything, there is nothing showing in that list. So let's go ahead and run task releases apply base. And we're gonna say yes. We do want to install basically everything that's associated with the storage namespace, so OpenEBS, raw file local PV, and a storage class for a storage class that our other workloads will be able to use. Alright, that has applied, and now is moving on to the ingress namespace. The ingress namespace contains three releases, so cert manager resources, and ingress nginx. Now I will apply this. However, while this is being applied, I will mention that our ingress namespace contains some additional customizations needed. So if we go to ingress nginx, in order for ingress to work, you will need to provide external IPs. So you will need to populate with public IPs of hosts so that you can accept inbound traffic. For the purposes of this demo, we will not be doing that. Alright, so at this point, our ingress releases and resources have been deployed. So the next thing would be Postgres operator, which is a requirement for the graph stack component, followed by sealed secrets, which is our current solution for Kubernetes secret management. This solution is, we're planning to update it to something different, but we are using an external solution for managing Kubernetes secrets because using the Kubernetes secrets out of the box that come with Kubernetes itself is not secure enough, because resources are encrypted only in base 64, and that can easily be decrypted. So we will see in a minute how we're going to do how we're going to use a sealed secret and what that means. All right. So at this point we have run task releases applied base, and we have Kubernetes and core systems running. We will in the next LOH session we will go into a lot of details of monitoring, so Prometheus, Grafana, Loki, and the rest of the stack. But for now, we will continue with deploying a blockchain namespace. And for the purposes of this demo, that namespace would be it curly. So going back to our Helm file, you can see that it curly. So this section represents the it curly definition. So you can see that the flavor is girly, running Ethereum namespace with the Ethereum stable release channel. Our Helm file already gives us a hint that we will need a secret to be passed to both Aragon and Nimbus. This is a JWT that ensures that the two can speak to each other securely. So for that we will need a sealed secret, as the namespace does not come out of the box with a sealed secret for JWT. And the reason being is that sealed secrets are cluster specific, so context specific and namespace specific. And to add in addition to the sealed secrets, we will want to do additional customization, but first let's define our sealed secret. So because if we look at Launchpad namespaces Ethereum, so if we look at the Helm file here, because it only contains Aragon, Nimbus, and ProxyD, we need to expand that to use sealed secrets, which creates to create a sealed secret resource. So sealed secrets works by the controller that we've already installed needs to be given a sealed secret resource that looks a bit like this. So and the controller takes this sealed secret resource and transforms it into a secret that Kubernetes knows what to do with it. So at the end of this whole process, we will have a Kubernetes secret. So let's expand this Helm file to add this release that doesn't currently exist. So the name of it, we will name it curly JWT because it is a JWT token. The namespace will be it curly. The chart will be GraphOps resource injector. Resource injector is just a handy chart we've created that can manage any release of any Kubernetes resource that you may need to manage with Helm. We'll add a label. This is to match the rest of the it curly namespace. So Launchpad GraphOps XYZ. and then namespace Ethereum, and then okay, and then the values of this chart. So resources, the name of the resource, which will be it girly JWT, and then here we will just copy this format because this is the format that Sealed Secrets accept. Now, as you can see here, so both Aragon and Nimbus expect a secret called JWT with the key of JWT. The namespace is it girly. Again, Sealed Secrets are namespace sensitive, and now we need a value that is encrypted that we can safely commit. So to do that, we'll go to our terminal, and we have so tasks, we have tasks, utils, Sealed Secrets, so a specific utilities that helps us encrypt secrets in a format with kubectl, in a format that Sealed Secrets controller accepts. And I'm running help to remind myself what the options are. So task Sealed Secrets, the namespace we're running against is it girly. The secret name is JWT, the key name is JWT, the value of the secret, this would be a JWT token. For the purposes of this, I'll just put a random string, and when I run this, and you can optionally pass a context name. This is because Sealed Secret is cluster sensitive, context sensitive. If you do not pass a context name, it will use the current context we're working against, so our demo cluster. So it tells us here that we're using the demo cluster context name. So this gave us a nice encrypted value, which we will add here. We'll save this, and we do so this is to create this new release that is not included by default in the it girly namespace. However, for both Aragon and Nimbus, for the purposes of this demo, I will be wanting to do some additional changes. So I'll just have a quick look at Launchpad namespaces, Ethereum, values. Okay, so girly, so Aragon comes with storage volume of 500 gigabytes. That is a lot for my demo, so I'm just going to reduce that. So copying this, now I think I'm going to give it just 10 gigabytes, and I'm going to do exact same for Nimbus. In addition to that, I'm just gonna have a quick look at Launchpad charts. So our Aragon chart in values, if I go to volume claim space. This has a storage class name. I want to specifically tell it to use a storage class name that I know will work for my cluster. And that is do block storage. Again, this is because this is a demo cluster. And otherwise, the storage class name should be the OpenEBS local PV profile. Alright, now let's see what happens when we deploy all of this. Task releases, apply, and we are deploying it curly namespace. So it will add Aragon, Nimbus, and ProxyD, which come out of the box with our Ethereum namespace. And then in addition to that, our new release it curly JWT. Alright. Now if everything happened as we expected it, we should see a kubectl get sealed secrets resource in Ethereum curly, and we can see it, and it's 24 seconds, and this sealed secrets should have created secret, a Kubernetes secret, the same namespaces. So if we do kubectl get secrets and it curly, we can see the JWT secret, and we can query that. Get secrets JWT-O YAML to see the full contents -n it curly and this is our value that we've encoded, stored in base 64, and if we decoded it should match what we encrypted earlier. So okay, so we're able to successfully create the secret. Now let's see if the pods associated with Aragon, Nimbus, and ProxyD have been created. Okay, so Aragon RPC daemon pod is running, the stateful node is creating, and Nimbus is creating, and we have ProxyD as well. If we look at logs, actually this is still creating, so this won't show logs. We can look at RPC daemon logs. Okay, this is sometimes an issue with K9s, so if I do kubectl get pods and it curly, kubectl logs, okay, we can see we have started Aragon, and same with ProxyD, they're both running now. this is the beginning of deploying our blockchain node. There will be additional customizations to be done, but we have successfully deployed it girly. For the purposes of this demo, we will skip the graph girly indexer stack, and then the next thing is quickly talking about updating Launchpad namespaces changes into your stack. To do that, well, we're already following latest, which is storage stable. So by default, every time we redeploy any of those, so every time we run task releases apply any namespace, it should update with the latest changes from, for example, storage stable latest that were pushed into Launchpad namespaces. However, if we do want to follow a specific version, as I have showed you at the beginning of this demo, you can update the storage v1 reference, and then you have additional details on how to update to pin to an exact version and how to follow the latest canary here. The last thing that we would want for this demo is to pull in starter changes, and to do that, again, we have a task. So task Launchpad. So Launchpad pull upstream starter changes. It pulls and rebases changes from upstream Launchpad starter into your current local branch. So ours is saying that we have the untracked file, helmfile.yaml, which it's true because we haven't pushed it and we're not planning to push it for this demo. And then nothing added to the commit because we are running against the latest Launchpad starter, but if there were, you would be able to see it here. So our branch is up to date with Launchpad starter. All right, this concludes our quick start. Please do ask us questions. For the next session, we're planning to show in more details how you can customize values of different releases. So we have showed you, for example, in It Girly, how you can use a different storage class name, use a different storage size. We will continue with that in addition to going in more detail into the monitoring namespace and talking about the different things you can do there. Please give us feedback and we will see you at the next LOH.